Okay, so we are Monday, July 17th. We are in the third week of summer school, almost done. So just a reminder that next Tuesday, Wednesday, and Thursday is for your independent study unit. In other words, you're culminating. And then you've got your final exam that's due. So don't submit anything past like 3 o'clock on the Thursday of next week, just because report cards are due on the Friday. So just as a reminder. So we've got quiz number 5 that's due today, as well as assignment 3, so we could finish up unit 3. And so this is the quiz real quick. So we're looking at confidence intervals. So a confidence interval uses, let me get my pen. So it uses sample data to estimate an unknown population perimeter with an indication of how precise the estimate is and how confident we are that the result is correct. And so it really tells us if you should be confident in the answer that you're looking at, if the result kind of makes sense. And if not, then a little bit more study has to go into that. So I am going to clear this. When we take a sample, we do our best to try and obtain values that accurately represent the true values for the population. So for example, if we took a simple random sample of 500 from a population of a town of 10,000 people and found that in the upcoming election, 250 or 85 plan to vote for candidate Y, then our best guess for the proportion of the town, so the 500 out of the 10,000, for the proportion of the town that will vote for candidate Y would be the 285 out of 500, or 57%. But if we don't know if the true proportion of people who will vote for candidate Y is 57%, for this reason, we report a margin of error. Oh, that's not what I'm supposed to do. So margin of error. So that allows us a little bit of mistakes. So a little bit of leeway. It might not be 57%. It could be 55. It could be 60. We aren't too sure, but it gives you that little margin of error or skew of information. So from this information, we can create a confidence interval. So the confidence interval will tell us with a certain percentage of confidence, usually about 95% is used, that the population mean will fall between some lower limit and a higher limit. So again, that margin of error. So you've got what you believe or what you're calculating is your percentage, but it could be at a lower limit and it could have a higher limit. So to take a look at the confidence interval, we say a computed confidence interval shows the proportion of confidence intervals of size n that actually contain the population mean. So here you've got 95% confidence interval for different samples. So in this example, the 95% confidence intervals for various samples are shown. Only 1 out of 20 does contain the population mean, meaning that there is a 95% chance that the population mean is within the confidence interval given by different sample means. So obviously there's going to be a formula because there always is. And so our X bar here, so we've got X plus or minus Z with the star, sigma over the square root of N. So our N bar is our sample mean. Our sigma is going to be our population standard deviation. Our N is our sample size. And the Z with the star is our critical value for confidence interval. So I'm gonna clear that. And then we're gonna take a look at a few examples. It's not too long of a lesson today. So this table gives us a list of common confidence levels and their associated critical values. So you've got your confidence levels on this side. We've got 90%, 95, 99%. And we've got our tail size, which is 0.05, our 0.025, as well as our 0.005. And our Z star would be the following numbers in the table as well. Okay, so you do have the independent practice questions that go with this, as well as your assignment to go along, and we can move on with a different unit. And that's really it for today. If you find you have extra time, catch up on any work that you need to, start working on your independent study. And prepare for the end. We've got our exam next week. So good luck.